Hello, am I audible?
Yes, sir.
Oh, fine. So, what we were discussing in the last class?
Sir, hello.
Yes, yes, yes.
Sir, video lecture that are given and the assignment are
Huh.
not helpful to, solve the assignment in this video. Sir, how can? Because I solve the problem here and there, and I think I have very problems, sir. I have facing to solving the assignment.
Are you following the
How can?
lectures taken by sir?
Uh-huh.
How many
Sir,
lectures
take,
have you watched
sir,
today?
today I already watched all the lecture for fourth week.
Okay,
But when I go for the assignment, then it's 30 to 40% to, give the I give to the answer. But other I have too much problem to finding the solution of that assignment. Sir,
okay.
how
Then
can?
actually, if it is so, then
But also
because
other subject I have also joined, but there I have no any problem. I mean whatever there is in lecture, they are in assignment also.
no. So we have instructed that we are not here to solve your assignments. First of all, let me be very clear, guys. I am not
Mm-hmm.
here to solve your assignment. I will not take questions whatever is given in your assignments. I am
Mm-hmm.
wanted to take a similar concepts which is related to your module and which could be helpful indirectly. I'm not saying that the question will what I will be here discussing you will from here you will get directly the similar thing and you will just take mark in your main assignment.
Not similar, sir. Also, whatever the in assignment question assignment is beyond that.
See,
Beyond that concept, sir.
first of all, it is not beyond that. Whatever I am taking in the lecture, it is
Mm-hmm.
already in the lectures, and the questions I am taking, I am not taking from here and there. This is a previous year, some past year questions assignments, which we are suggested to take. We cannot take this year's questions for your assignments. Although it could be helpful if you will say that I should have some more questions apart from what is given in the past year, that I can try from my side. But the questions here I am taking is from your previous year questions from your previous assignments, and it is regarding to your this what you said your course only. I'm not taking from any other courses, even though the slides are also from the your NPTEL. I'm not even making my own slides so that you won't be distracted from my content, whatever you have watched in the lecture.
Mm-hmm.
So if it is so, then I will surely try that. If you will come with your questions like that, then maybe, or if you can post me a mail, something like that, that this kind of a question you want, because here I am randomly choosing a questions regarding to your module. What is what has been taught in your lecture series, but the thing is I'm trying from my side. I have not even seen your what is your assignments and what is your exact questions, because I cannot solve the exact questions.
Sir, last session, sir, for the numerical problem, we have also I don't solve that problems are also now.
Okay, so have you tried sometimes? I
I
cannot take
tried.
so
I
many
tried, sir,
questions.
but not to help to solve the problem.
Okay. Okay, then I'll try to include. I have not seen the current assignments. This is the previous year assignments question. So from there I'm taking the question. But as per as my observation is that if it is like a 15 question, I think only one or two or hardly three, not more than three would be numerical. Most of they are like from the subjective only, theory part. Is it like that or
Yes,
is it different?
yes.
Okay. Okay. So guys, how many lectures have you watched for today's session?
The whole lecture was, sir.
Okay.
Like,
Then I hope you would be able to give answer for my questions. Okay. What about others? So Arun is saying 4 lecture. Afzal already said that he have watched all the lectures. What about others? Tell me, otherwise I have to call your name. I can see your name here in my participations. Sudhir is saying only 1 lecture. What about Nikshita? What about Nivedita? Please you also tell what about Yashika? Not responding. Are you even in the class or not? Just joined and went somewhere. Yashika is saying 1. See, the people are not even watching the lectures. See, guys, I mean, just uh, be very sincere to the classes. I know that even if you can't watch that, at least try to watch at least 3 lectures. It won't take much of your time. Because if you will watch, it would my work will be little easier to to let you understand, and then only I can take a more questions. Otherwise, it would be a because you all are from a different background, so I have to explain you in such a manner that you all can be on the same page. So that's my request to you all. So um, but anyways, let's begin. So
sir, last session question can we solve, sir? Can
uh,
we go
yeah.
with the next?
What was the question actually? Actually, I this week I was fully occupied for
Spherical aberration of 0.5
okay.
millimeter. Find out.
What have you done for that question?
Sir,
I have, I think,
whatever
given you
the
some hint, right?
yeah.
So did you solve by that?
Yes, sir, solve, but not finding.
Huh?
Not find, sir.
Not
I
found.
didn't find.
Okay, actually, I just gave the hint, but I did not solve that question because this week I was outside. So where was the question? I think that slide I forgot to include that slide actually. Uh, okay, actually I will see because that slide I think the last week's slide is not here. Was that in your assignment, the same question?
Yes, sir.
Okay. And apart from that, have you solved the other questions?
Solved, sir, but I got only 60%. Too much.
You got only 60%.
Yeah.
What about theory portion?
Theory person, I thought, that's why I told you, na, this too much hard discussion. Not
And what
whatever
about
the assignment, not similar to that video.
okay?
Assignment
And
question is different from the video, sir.
yeah, that would be different, obviously. But Okay. And what about others? How are you doing your assignments? Are you performing well or average or below average? What's your status? Yashika is saying average. What about others? How are you performing? Nikshita is saying average. Okay. Okay. I mean, you all are somewhere near to 60, 70, 75%. Okay, fine. Okay, then slowly you have to, because you all are from different backgrounds. So like last class I have already suggested to make some notes that would be even helpful for your assignment. So let's see, I have tried to collected some relevant question for this time also. So let me just go through it, and I hope that if you have seen your this questions, then hope I will try to solve as much as question for this week as I can. So, should we start from this?
Yes, sir.
Okay. So, this is regarding the Monte Carlo simulation. Okay. So, usually this is a one kind of a simulation that is that tells about something. So it is saying that you have to out of these four options, that you have to choose the most accurate one, that this simulation is giving you which kind of information or what does it provide. So like trajectory of electrons, mass thickness variable, scattering angles, or the traces of elements present in the specimen. So, can you tell me if you have like Monte Carlo? It is one of the very famous simulation, Monte Carlo simulation, and it provides some information. Do you have any questions in your assignments regarding Monte Carlo? Okay. So, what question was it? Same or different? Okay. Okay. Fine. Yeah. The main thing is you have question from Monte Carlo. That's what I wanted to say, because here I it should not be that I'm discussing something out of the box that is not in your assignment. So at least okay, I'm glad that some concepts are there in your assignments. Okay, then tell me that. Okay, someone said the A. What about others? Trajectory of elements, mass thickness. Yes. Okay. So yes, actually it is true. The trajectory of the electron. The main thing is if you will see when your electron is interact with the samples, this kind of trajectory or the path that follows actually. So when the electron will interact, the actually I mean in the principle of SEM, you will get electrons from a different depth of your samples, and that from the depth from which the electrons are coming, that will decide that what kind of information that will give. I think somebody is not mute. Please mute yourself. So yeah, that will give. Yes. So that will give you the path of your electron. Okay. So what is happening here in the scattering situation? So the probability of an incident electron suffering and scattering events while traveling any distance. Okay. So this scattering is given by this Poisson equation. Okay, so this is a equation of your Poisson equation. So this is Pn is what? This is probability. Okay, 1 by factorial n x upon lambda to the power n exponential minus x upon lambda. So this is probability. So P0 is very initial. The probability of electron not being scattered. Not being scattered means it has not interacted yet. Okay, so that's why it is at very initial. And since the probability is 1, so if we will subtract 1 minus P naught or P0, the probability of it being scattered once or more. Okay, so I hope that you all know this very basics, this probability. So if something is having a probability of suppose the incident A, occurring of incident A is having a probability of P naught, then what the incident of occurring B has probability will be 1 minus the initial. Okay, because the probability can be 100 or it is denoted by 1. 100% means 1. Okay, yeah. So in this way probability is given. So P0 is what? Where your electron is not getting scattered. But 1 minus P0 is what? Where your electron is getting scattered. Now, now the Poisson equation approach is not much used for multiple scattering. Okay, when you will have a multiple scattering, then this equation is not much in use. Okay, where all primary electrons can be assumed to be scattered very many a times. Okay, because here they are assuming that it has scattered many times, possibly by several different mechanisms. So in these cases, other averaging approaches are more fruitful. One example is, so this is the one example of your Poisson equation. So from the Poisson equation, you cannot get a multiple scattering by using this equation. So what you will get, from where you will get, it is a from Monte Carlo method. So from Monte Carlo you can get a various, I mean if there is a multiple scattering, then instead of a Poisson equation you can use a Monte Carlo method. So Monte Carlo method will mainly give you the trajectory of electron, that what is the path of electron when it is interacted with your specimen or your samples, and how it is during the scattering, what kind of a path it is following. Just you can see there are so many zigzags. Some are getting up to this depth, some are getting scattered from this depth. So this is the trajectory basically. So this suppose if it is a very random, then there must be something that you can calculate and then, or that you can simulate to get a main trajectory or the trajectory of the electron. So that you can get from where, that you can get from the Monte Carlo. I hope it is a little bit clear. So the trajectory of the electrons you can get from the Monte Carlo simulation or the Monte Carlo method. Is it clear? Is it clear?
Yes, sir.
Others, please respond. Okay. Should I go ahead?
Yes.
Okay. The next question is, out of the given options, which one is real concept and can be observed in an electron microscope? Mean free path, interaction volume, interaction cross section, scattering angle. So if you have like after this the simulations and how I mean what kind of a shape you will get, this is regarding that. So if you have seen the lectures, then it is very easier for you. So out of these options, which will give you the real concept and it can be observed in a electron microscopy as in you can say like scanning electron microscopy. So yeah. I hope you have seen the options. And so uh, okay, let me also, what is so Afzal is saying C, Devika is saying interaction volume, and others are also saying interaction volume. What about others? I won't respond from you all. So at least give some response. Did you get the questions? B. So I think most of you all are saying options B, interaction volume. So let's go through it and let's see what is the correct answer. So it is asking about the electron microscopy. Okay. So yes, interaction volume. Interaction volume means the option B is the right one. So what is interaction volume? When your electron beam is coming. Okay, just now I have explained in your Monte Carlo method that the different trajectory paths. So if you will simulate something, this bell kind of a shape it will form. Okay, earlier it was like this. So if you will see, and if like it could be like this shape. Okay, in starting it will be like this, and then it will rotate, and it's like a bell shape. Okay, dumbbell, or you can say like that. So the reason generated because of electron specimen interaction is interaction volume. Okay, so electron is interacting with your specimens at a different depth. Some electrons are coming, it is getting scattered from this depth. Some electrons are coming scattered from this depth. Some are from this depth. So various depths, from various depths, the electrons are getting scattered. So this region is generated. So this will generate this kind of a region because of this interaction of your specimen and electron. So this region generated by this interaction is called interaction volume. So usually when I hope that last time I have explained that what is elastic and the inelastic scattering. So in the elastic, actually this is conservation. The electron will come and it will rotate. There won't be any loss of the energy when the electron will interact with your specimen. It will not scatter from at any angle. But in elastic, it is not like that. So in inelastic scattering, together distribute a so in this both together distribute a single incident electron beam over a three-dimensional region inside the material. Okay, so when it will come and distribute, so it will distribute over a 3D region inside the material. Some are from this side, some are from X and Y and G directions. So that's why you will get a different trajectory for the electrons path, right? So size and shape of the interaction volume. Okay, suppose in sometimes the shape or size could be different. It could be smaller, it could be larger, for depending on the specimen, on the relative amount of elastic and inelastic scattering on electron beam. So how you will decide the shape and size? This could be also the your assignments question. I'm not sure that it depends on what. It depends on the elastic and the inelastic scattering on electron beams. So let's say this is like a inelastic scattering. So and there will be the transmitted electrons. Some are elastic scattering, some are incoherent elastic scattering. So there are different kind of scattering is occurring when your electron is when your electron is interacting with your specimen. So just now you can see this is your electron beam is coming. Here is your sample. You will get what? Secondary electrons. You can get backscattered electron. You can get continuous X-ray. You can get Auger electron. You can get characteristic X-ray. You can get cathodoluminescence. This is your samples. This is the depth of your samples. Okay, so you will get interaction volume. So here when you will see a size and the shape of your interaction volume, this varies actually. Again, how? Depending on the scattering, what is your scattering, elastic and the inelastic scattering. So the direct measurement of interaction volume for materials with intermediate and high atomic number material is not possible. Okay, so you can't measure this interaction volume directly for materials with intermediate. The material, some materials are having of a very high atomic number or intermediate. So it is not directly possible. Etching plastic can directly reveal. Just a second. Yeah, sorry. So the etching plastic can directly reveal the interaction volume for the low atomic number. Okay. But it cannot do the same for the intermediate or the high atomic number material. So it is just saying about that if you will have a different atomic the samples of your different atomic numbers, then how you will measure your interaction volume. So every kind of a samples can have a different measurement techniques, which is so that is not very relevant for this slides. Here just I wanted to say for the different materials you can get here the size is bigger, the size is medium, here the size is very small, here the size are even the more smaller. So this size varies interaction volume. Okay, so mainly the answer for this, what was the question, real concept and can be observed in electron microscope is what, interaction volume. So yes, most of you were right, the interaction volume we observe. Is it clear? Any doubt on this? I hope I have made things clear.
Yes, sir. Okay.
Okay, fine. If you don't have any doubt, then I will go ahead. So, yeah, this is again from your interaction volume question. So, I will try. This is very main concepts and basics of your electron microscopy. So, you will get because every signals and every electrons coming from your specimen gives a different informations. So, that's why it is very important. So now the question is, Auger and the secondary electrons are surface events only, bulk events, intermediate events, bulk and intermediate events respectively. So yeah, what is your answer for this?
Hello, sir.
Yes,
Sir, I have a doubt. Professor will join this class or
Professor. No, actually, uh, he does not join. So what you want to say? I mean,
no? I was asking. The link was different, but the time is from 7 o'clock. So how will we join?
what I didn't get your
Um, interactive class with the professor is today, right?
today.
Or
Okay,
no?
I do not know. I because this is a different.
Was today. Okay. I think it's today. Can anyone please? If
Yeah,
it's
you
not
can.
today, okay. Then I.
I'm not sure because I do not get information regarding.
Sorry, I will check again. I thought.
No, no, it
Okay,
could be
okay, okay,
possible.
okay, okay, sir.
Is it like that? Okay, so someone is saying today. Okay. So,
Yes, sir. Today only 7 o'clock.
okay. So actually what I
So
will do, I will just because the link is surely different. I have not informed for this because my session, because I cannot postpone this sessions because this is conducted by the NPTR only. So they also comes and check sometimes that whether the class is going or not. So what I can do for this is that I will take the class and I will take the questions and I will upload on YouTube. For don't worry. And uh, the one more thing, if you will if you like after this, if you want, you can watch from the YouTube video. Okay, will it be okay?
yes, sir. Yes, sir.
Okay, yeah, because actually the thing is I cannot stop the lectures. So we need to join the other link. I think if you're, I do not know that what kind of a sessions you have today, but if you want to join that sessions, definitely you can join. It's not okay. So I will continue the class. If somebody wants to join the sessions, then definitely join. So should I go ahead? Arun, actually, you don't need to go for the live sessions. I have my own YouTube channels. There you can directly watch the lectures. If you want, I can give you my, just a second.
Sir, actually, live section by the sir is in a YouTube live section.
What? What is this that you have ever shared the live session, something like that? Okay, is it something like that? Okay, sorry. That okay, that was not. Oh, sorry. Sorry, guys. By mistakenly, I logged out. So, okay, let me just go through my channel. I will share the link. Okay, so uh, okay, so can so can you see this? Here in the channels, I upload every week, and in fact, you can get from the previous years also. But the lectures was almost same. But here I'm taking it again, and I have uploaded the past 3 lectures on the YouTube channels. So even though if you can't join the lectures, you can watch it from there. I hope is it clear? Okay. Above link is a link for professors live sessions. Okay, that's good. Can you send me that link again? Okay, I'll see. Okay, so I think it's going to start on after 2 minutes. Okay, okay, fine. Okay, so I'll resume my class because it's not for me. So yeah, those who wants to join the sessions, definitely they can join. And other I'm here taking the class because I cannot stop. You can watch it on YouTube also. So yeah, can you tell me the answers for this? Auger electron and secondary electrons are what? So people are saying A. Okay. So yes, actually it is like that, because here just now I have said that when the electron is coming, suppose your electron is getting scattered from the very near to surface, let's say a 10 angstrom of the thickness, then it is your other electron. If it is from the 50 to 500 angstrom, it will be your secondary electron. But after that, if it is getting scattered from your depth like this will be your backscattered electron. And when it is getting deeper and deeper, so your different signals will come, like your characteristic X-ray, continuum, fluorescence. So different you will get. But here they are asking that about the Auger, specifically Auger and the secondary electron. So this is from the surface only. Okay, so this gives the surface events. So the size and the shape of interaction volume is limited by two factors. What are that two factors are? Energy lost through inelastic scattering. Okay, so when it is coming, interacting with the specimen, then how much energy it is losing? Electron loss or backscattering through elastic scattering. Again, it is about the inelastic. This is through the elastic interaction. So a beam of electrons lose energy as they traverse the samples due to interaction with it. Okay, when your electron will come and interact with your sample, then it will lose some energy. If too much energy is required to produce an effect, it will not be possible to produce it from the deeper portion of the volume. Okay, what it is saying, when too much energy is required to produce an effect, okay, too much energy means electron have to go to the very deep, it won't be possible to produce it from the deeper portion of the volume, so electron will getting scattered from your nearby depth. Okay, so is it like that? But here it, if it comes to your surface, then it will be your secondary electron and the other electron. So I hope that it is clear. Okay, surface events. So I think it's 7 only, and if you want, you can join the sessions also. Um, if you want to go, otherwise I'll. Are you guys, are you guys joining the sessions? I think it has started. Let me just check. Oh, I think it's from 7 p.m. Okay, then we have some more. Okay, fine. Now it is again regarding the same, the size of the interaction volume and the penetration depth. Just now, I think few minutes ago, I have said, and these questions again. So can you tell me? I have told enough about the interaction volume, and what are the factors that are affecting the interaction volume, how it is forming, what kind of information it is giving. So I hope, I am expecting that you all will give the right answer for this question. So just try one more. People are saying A. So yeah, what was the answer? A. People are saying A. Okay, just a second. My screen is getting hang. So yes, the increase with so here the option A is saying increase with increasing electron energy and decrease with atomic number. Okay, of the material high scattering. So let's say whether the option is A is correct or not. Okay, so this is again when you will get the trajectory of the electron, you will get something this kind of a shape. So Monte Carlo simulation, trajectory simulation provides an indirect method to visualize the interaction volume, okay, for any material. A large number of trajectories, typically 10,000 to 100,000 electrons in the beam must be calculated to achieve statistical. So see how you will get. There are a lot of electrons are coming and interacting and scattered as being taking place. Scattering is being taking place, and there are so many trajectories around more than 100,000. So this is a statistical method using random numbers for calculating the path of the electrons. Now, the probability of scattering is taken into account by the program as well as important parameters like voltage. Here you will have so many different parameters. Voltage, you have to give some parameters. Okay, so Monte Carlo simulation is a simulation where, so in any kind of a simulation you have to give some kind of a parameters and all for the simulations to taking. So here also it is saying that there are some important parameters, and what are those parameters? Voltage, atomic number, thickness, density of the material. So these will affect your scattering, isn't it? So although such calculations are rather rough estimates of the real physical process, the results describe in the interaction and in particular the shape and the size of interaction volume this level. So this will actually what it is saying, the result describes the interaction In particular, the shape and the size of the interaction will also change when you will change the parameter. Okay, so these are some parameters. Why have we introduced this slide? Because this is saying the parameters. So in the question, it is about the voltage. Yes, voltage will affect this, and the atomic number will also affect. So here, as you can see in this slide, it is saying that your voltage affects the interaction volume, atomic number also affects, the density of material will also affect, thickness will also affect. So how it will affect now, the slide is here. So okay, let's instead of me speaking, rather just from by me only. For this, I have also opened the slide. Can you give me your logic that how A could be the right if you have said, and if you can guess the others also? It is very just simple, and the slide is here also. I have also said that. So I will give you the chance at least to explain me, or even if you don't want to speak, you can just write your logic that why it is A or why it could be other options as per your, I mean, how what is the relation between the voltage and the atomic number with the interaction volume and the penetration depth.
It is all directly proportional.
That is very good answer. That it is, I'm not asking that it is directly proportional. I mean, how, why, something like that. If you want to say that if the voltage is increasing, then why the interaction volume is increasing? I'm asking why.
If the voltage is increased, it is then electron velocity will be increasing. Kinetic energy will increases.
Okay.
So when kinetic energy increases, automatically the penetration of depth increases. So that the interaction volume will be larger.
Okay. Yes, that's true. Right answer. Others also, did you get it? Got it or not?
So
What
there
he
are
has. Yes, somebody was saying something. Please tell me, did you get it or not? What he has explained. Or do I need to explain? If you will say that I should explain from my side, then only I will explain. Otherwise, I'm not going to explain because I am the only one who is explaining. So it's so what you want? Is it understood? If not, then I'll explain only. Just type in the chat box. Do I need to explain? Yes or no? Hey, what it is? If you want anything, then I won't explain. If you will say, then only I can at least tell something. Okay, yeah. So people are saying no need to explain. Understood? Okay, fine. Did people said yes also? No, I think this is. Oh, some people said yes also. Nivedita, Nivedita, Arun, do you want me to explain it? Afzal. Okay, no. Okay, good. Okay, fine. So, what he said, that is correct. And this is the things, and yes, this is the plot for that also. So here, this is just same thing, that here your voltage is increasing, and when you will see, the higher will be the voltage when you're increasing the voltage from the 5 to 50 kilo electron volt, where interaction volume is increasing. But when you will go from the higher, so from the lower atomic number to the higher atomic number, here this is decreasing, the interaction volume is decreasing. So yeah, that's fine. And if you're not, then it's very good. So you are right. Now, the contrast generation in transmission electron microscopy images can happen due to the effect of what? Mass contrast only, thickness contrast, amplitude phase contrast, all of the above.
All of the above.
Okay. What about others?
Sir, excuse me, sir.
Yes.
Sir, the live session with the professor is there now today at 7 o'clock.
Yeah. I just got to know. So if you want to join, you can join.
Okay, fine.
Yes. Is it started?
No, sir,
It is
until
not started.
So what was the time?
7.
But it's already 7:10.
Yeah,
So when it is going to start?
we don't know. We are waiting.
Okay.
now it started, sir.
Okay. So fine, if you want to join, you can join there. So are you people are here or are you joining? If you want to join, you can join, or should I go ahead with the lectures? Okay, here. Okay, okay. Actually, maybe I'm not sure because I have not been informed. So it could be probably for that. How you guys are doing with the lectures? Are you if you want, you can share your suggestions. Maybe it could be from the how your live sessions are going, how I'm dealing with the questions, how I'm explaining, whether able to explain the concepts. I think somebody said that it has started, Nivedita. Just see that. I think it has started. Somebody just said. So maybe it could be they will ask regarding this and how are you doing with the subjects. No, it has started. Just check once again. Yes, it has started. So if you people wants to join, please feel free to join, and you can watch my lectures on YouTube also. Okay. So yeah. So if people are here, then please view the answer for this question. The contrast generation in transmission electron micro image can happen due to effect of what? Please tell me. And also I think some people were saying that if you want you can also join the lecture there. You can also say, like, some people, I think some people they starting saying that they are facing some assignment problem. So if it is not from your lectures, then you can say to sir also, sir, it is not available in the lectures, whatever the problems or the assignments you are getting. So that would be, I think, helpful for you also to solve your assignments. Can you please tell us the name of? Okay, sure, sure, Yashika. I'll surely tell you. I uh, just
Sir, excuse me.
yes.
Sir, actually, Sir has came in live session.
Okay.
He's asking for chat box, but it is the chat box is not active. It is hide. We cannot give input. How should I inform to them?
Oh, really? I do not know actually.
Yeah.
Is it like that? Others, please respond to him if you all can help of him.
Yes, yes, sir. Live chat is not available on sir.
Oh, okay, okay. Then I do not know that how can I help? I do not know because actually I because here it is not like a Google Meet na, that where you can unmute yourself and speak. Okay, so somebody was asking my YouTube channel, so just let me give my YouTube channel firstly. Just a second. So Yashika, for your reference, I hope that you would be able to see my channel from this link. I hope. Just try to click them and save this link. We can post questions. Yeah, actually there is one more thing, because I'm taking care of the live sessions. There are some more TAs who can answer your queries in the forum sections also. There you can just post your questions in the forums or the forms. There are multiple TAs, so sometimes even though if I could not able to solve your problems, then definitely you can post your questions there also. That is also a good platform. Okay, so yeah, so let's begin. I will not deviate from my lectures because I don't want to waste my time. So just tell me about this, then I can go ahead. The contrast generation in TM image can happen due to what effect? So tell me very quickly. I should not spend much time. Actually, Arun, professor will not will answer. I do not know about the professors, but there are multiple TAs. They will definitely try to answer your questions in this forum. Okay. Do you have any other questions, or should I continue with my lecture? Okay, then tell me very quickly. Nobody is giving response. Again, you people are not giving any response. Okay, then I'll only explain to you. Okay, so the contrast generation in electron microscopy. So yeah, so here how it is. So here can you see these are some dots, just these are some dots. So can you see these are very darker, these are lighter. So there are the contrast difference. So the simple model of elastic scattering by Coulombic interaction of electrons with the atoms in a material is sufficient to explain basic contrast. Okay, so there will be Coulombic interaction will be there of electrons with atoms. So electron is coming, interacting with your samples. Your sample is what? It consists, it made of what?
सर
Atoms.
सर स्क्रीन शेयर नहीं हो रहा है सर.
Oh, really? Oh, I'm sorry. Okay, okay. Okay, actually, I forgot. Okay, okay. Okay, sorry, sorry. Okay. This was the question, guys. So I will again start from here. The contrast generation. The contrast generate. The contrast generation in TM image can happen due to the effect of this. So this is the slide where you can see. Okay, so here these dots are. Is it visible now? My slides are visible. Visible now.
Yes.
Okay. So are you guys attending the search sessions? Is it? Can you post the questions now there?
Sir, there is no live chat, sir. Open.
No live chat, but some people said there is a live. Can you please share the live chats if people knows the link?
So actually, we can post a question using the doc forum. The sir will look into the forum and answer the question in the live YouTube.
Actually, Arun, it's like it's not like that. I can also do that, but the thing is like I am mainly taking care of this live sessions. But surely, when you will put your questions on the forum, definitely the others
No,
they
sir.
will.
No, sir. I have shared a link, forum link. In
Okay.
that link, we can post a question. The sir will look into that question and answer that in the live section.
I cannot say the sir will look because sir is definitely.
Yeah. Yeah.
I'm
If
not.
you open the link, we can say that it's showing that we can post the questions for the live interactive section.
Okay.
If you open that link, you can see that the forum title is like that only.
Okay, just let me go through it. Live interaction. Okay, so choose your question. Uh, yeah, you can please write your question. It is there now. You would like. Actually, it is to ask the professor. Professor. So there, his TA will respond. There are multiple TA on behalf of him. I feel so. But if something is like that, that is very concerned. And if TA cannot respond, then definitely professor will respond. And yeah, if you want a separate interaction session, then you will also say here. Okay, this is technique. Okay, fine. Okay, yeah. Oh, this is the same one. Okay, yeah, fine. Okay. So here, as you can see, there is a difference in the contrast from this place to this place. So the simple model of this elastic scattering by Coulombic interaction of electrons with the atoms in a material is sufficient to explain basic contrast mechanism in electron microscopy. The contrast between two adjacent area in TM images can be defined as the difference in the electron densities in image plane. Okay, so here, there you can see the contrast difference. Why? Because here the electron density will be different than this place. Due to the scattering of the incident beam by the sample, okay, when there will be the scattering, the amplitude and the phase, this is the main, the amplitude and the phase of the electron wave change. Did you get it? Suppose electron beam is coming interacting with the samples and the amplitude of your electron wave and the phase will change, which results in amplitude contrast and the phase contrast. Okay, so the most of images have both contrast components. Amplitude contrast is what is obtained due to removal of some electrons before the image plane. Suppose your electron beam is coming, it has certain amplitude, and when it will interact, then due to the removal of some electrons before the image plane, amplitude contrast will generate. And during their interaction, what is happening with the specimen, some of electrons will be lost. It is coming, interacting, and some is lost. Why? Because of the absorption or due to scattering at very high angle beyond the physical limitations of microscope or are blocked by the objective aperture. So that's why this amplitude contrast is generating. So the TEM high resolution micrograph of gold and titanium oxide catalyst, here you can see. Okay, this is very high resolution. Just see the scale. This is 5 nanometer. How smaller? So this would be around 2 nanometer of dot. This is around 1 to 2 nanometers. Very, very small. So nanoparticles. So here the mass contrast is what? The likelihood. So here you can see incident electron beam is coming. Here you will have a lower mass samples. This is your higher mass. So when it is incident beam is interacting from the lower mass, mainly you won't get, it won't deviate much or it won't scattered very highly. But when it is interacting with the higher mass, because of its higher mass, it will scattered much. So that's why this intensity profile for the lower mass is different than the higher mass, isn't it? So the likelihood, some echo problem or what? So the likelihood that an electron is deviated from its direct path by an interaction with atom increase with the number of charges. Okay, so it is saying the direct interaction with an atom increases with the number of charges that the atom carries. So therefore heavier elements, okay, this is your heavy element, represent more powerful scattering. So here you can see electron beam is straight, it is scattered at a high angle centers than the light element. It is not scattering much, so here you will get not much scattering. Now, due to this increase of the Coulomb force with increasing atomic number, the contrast of areas in which heavy atoms are. So with increasing atomic number, the contrast of areas in which heavy atoms are localized will appear darker. Okay, here your heavy atoms, so it will come darker, will appear darker than of such comprising light atoms. This effect is because of this effect is known as mass contrast. So here definitely it is saying, if you will have a two samples, one is lower mass, one is higher mass. Your lower mass you won't get much scattering, but in the higher mass you will get many scatterings. That's why the intensity profile will different, and you will get a different contrast in both from the lower mass and the higher mass specimen. It is mainly because of your atomic arrangement or the heavier or the lighter atoms. Is it very simple? Now the thickness is also somewhat similar. Here also this is your, the number of actually occurring scattering even depends on the number of atoms that are lying on the path of the electron. Suppose your electron is coming, if it is thicker but thicker sample, more the number of atoms, more higher will be the scattering, because it is interacting with the more number of atoms. If the thickness is less, more number of atoms will come in the path of the electron, so that the interaction will be less, isn't it? So as a result, there are more electrons scattered in thick samples than in thin ones. Okay, here we will be having a higher number of electrons, so the scattering will be higher. Okay, this is very simple. Thick area appear darker, so that's why you will get a different intensity profiles. Here you will get a darker, and here you will get a slightly less darker. So the effect is less to leads to the thickness contrast. So it is also somewhere similar to the mass also. So mass and contrast are like this. It's mainly depend on the scattering, which the scattering, and further this scattering depends on the thickness as well as the mass of your material. So the answer was the all of the above. Okay, so here mass will also affect, thickness will also affect, amplitude and phase will also affect. Now you tell me, is it clear or not? Clear or not? Type in the chat box. Yashika is saying yes. She is giving thumbs up. What about others? No response. How will I know? Now you tell me this answer for this question. If the previous question is clear, then this would be a little more easier for you. What will be the contrast generation due to atomic number effect of TM, bright field image of an alloy containing aluminum copper? So just I have explained, and if you have understood the concept, you tell me the answer. Yeah. What was the answer? At least tell me. I have explained the last slide very thoroughly. Then I think you would be able to explain, or you would be able to give the answer. It is very simple. Just now I have explained the effect of your, atomic number and all, how it will look. Just correlate with this. I have explained mass, thickness, atomic number. Aluminium is what? Lower atomic number. Copper is what? Higher atomic number. Just correlate like this. It's very easy. Okay. So the people are saying aluminum will be brighter than copper. Let's see. So the bright field imaging. So atomic number contrast is what? This is the particle. Here you can see the particles with a size several 10 nanometer appear with black contrast since AU. The gold, here you can see gold is what? Heaviest element in the system, and therefore it will scatter many electrons. So if the atomic number is high or the heavy element, the scattering will be more because of the more number of atoms present. So now the AU particle are crystalline, and as a result, black contrast contributes to the dark contrast as well. The titania supports appears with an almost uniform grayscale. However, with thickness of the area in the upper right corner of the image is greater as indicated by darker contrast, their thickness contrast. So it is mainly saying that if it is heavier element, then a more scattering and it will appear darker. So that's why the copper is heavier element than the aluminium. So it will appear dark and aluminium will be brighter. So yes, you are right. Aluminium will be brighter and copper will be darker. Is it clear? I hope it's clear. Now tell me this. In taking selected area diffraction pattern, where is the said aperture is placed? Before the sample, back focal plane of the objective lens. After viewing screen, there is no specific place. Yes. Please share live session links. I think somebody already shared the session links. Let me. I think this was the. So yes. So here you can see. Okay. So this is your schematic. That this is your condenser one. This is your condenser two. Upper objective, lower objective lens will be here. Objective aperture, and this is your SA aperture, selective area. Okay, and this is your for bright field imaging. This will be like this. This is for SAD, selected area diffraction. So for the selected area diffraction, it is asking that where is the SAD aperture. Okay, so where it is, your SAD aperture is here. Okay, so it is asking before the sample, back focal plane of the objective lens after viewing the screen. So where this is your objective lens. So just guess where it is. This is your SA aperture. Definitely it is not after the viewing screen, because your viewing screen is here. Your objective before the samples. Okay, so where is your sample? Sample is here. Before the samples it is not there. Now what is the left answer? Back focal plane of the objective lens. So here you can see where is your SAD aperture. This is your aperture. So this is your samples, not before the samples. This here will be your viewing screens. So it could be somewhere back focal plane of the objective lens. Okay, so this is your objective lens, not before the samples, not after the viewing screen. So it is back focal plane of the objective lens. So this is your objective lens. Okay, and this is your aperture. So this is where at the back focal plane of your objective lens. Because two answers have eliminated, which is before the samples definitely not, after the viewing screen definitely not. So the right answer is your back. It is not something very conceptual. It is regarding the instrumental fact. I mean, so where what kind of a parts are subjected. So it's like that. So yeah, I don't need to explain it much. Just see proper that it could be asked in your assignments, that it could be asked where is your hadaf or the bright field detectors are where, and your prisma is where, viewing screen is where, your projector lens. It could be asked anything. Where is your X-ray detectors? So just see this pattern, and it is very simple. Now tell me the answer for this question. Scattering angle of electron diffraction in compared to X-ray diffraction is what? Smaller, bigger, same, or depend on the material? What could be the answer? Somebody joined now. Why so late? So thing depend on the material. So let's see. This is your electron diffraction pattern. An electron beam which has passed through a thin specimen contains two components, elastically scattered electrons and inelastically scattered electrons, which I have already explained. Now the electron diffraction pattern, which is spatial distribution of the scattered electrons, it helps to deduce the information about the arrangement of the atoms in the specimen. So to explain the diffraction regarding the electron as a particle is not sufficient and its wave properties must be taken into account. So this is how your diffraction is getting placed. Here you will get, you can see the incident plane waves, and these are the diffraction envelope, and get you will get a different diffraction, okay, depending on what. So as you can see, this is your incident beam or the radiation, this is your lens, this is your object, and this is your diffraction pattern you will form. So here this is depends on your optics, and here you will get some pattern. So here the same thing you can get here also, you can see here also in the single crystal this kind of a dot which is nothing but the diffraction pattern. So that's why for any samples, how you will be able to analyze that what kind of a crystal structure your samples have. Okay, so this is nothing but mainly you will get certain shape, like a different crystal structure is having a different diffraction pattern, such as you can say a cubic or a tetragonal or the hexagonal. So it depends on your diffraction pattern. Okay, and this is your magnified image. So now when the scattering of electron, so the intensity of elastic scattering from a particular atom species, okay, is maximum when the scattering angle is 0. So suppose your electron beam is coming and it is not scattering, then you will get a higher intensity. So here you can see at scattering 0, then intensity is higher. When you are deviating from your angle, your scattering is your intensity is getting reduced. Okay, it is very simple because no scattering, your intensity will be high. The same thing you can see here at the center, this the intensity is higher, and when you will go far from this, you will get a lower intensity. Now, the variation of scattered intensity is more complex as there are some diffuse maxima in the intensity. Diffuse maxima, it means what? Here, your maxima at the center it is higher. Now it is starting to diffuse. Your intensity is getting reduced because of the variation is scattering angle. Now, diffraction pattern from a thin film of amorphous carbon, and B is a graph of intensity. Okay, so this is a diffraction pattern here you will get, and this is your intensity as a function of scattering. Now, this is your scattering, incoherent scattering of the incident. Nearly coherent electrons takes part if the scattering centers are arranged in an irregular ways, especially in an amorphous material. This is your amorphous materials where your atoms are randomly oriented, not in a very specific manner. This is your polycrystallines, and this is your crystalline. I mean, it is a very well arranged. Okay, and this is are also arranged, but at some part it's some, randoms. Okay, like this will a different crystal. It will make a different crystal. So although the scattering happens predominantly in forward direction, The scattered waves have arbitrary phase in respect to each other. Now, enhancement of the wave intensity because of constructive interference in certain direction cannot happen. So again, it is saying that when your electron is interacting with this kind of a crystalline, so here your atoms are very well arranged. So scattering will be different as compared to when it will interact with the amorphous material. Okay, so again it depends on the material. Some materials are crystalline, some materials are non-crystalline, some materials are polycrystalline. So the scattering crystalline material specimen is transmitted by electron with a certain wavelength. Then coherent scattering takes place. Okay, when you will have a crystalline sample, coherent scattering will take place. Now, all atoms in such a regular arrangement act as a scattering center. Okay, so these atoms here will act as a scattering centers that deflect the incoming electron from its direct path. Isn't it? Here you will have a different atoms. Now these atoms will act as a center of your scattering. So this occurs in accordance with the electrostatic interaction of the nucleus with the negatively charged electron. Now, since the spacing between the scattering centers is regular constructive interference of the scattered electrons in certain direction, and thereby the diffracted beams are generated. So here you can see the incident beam is coming, and here it is a scattering direct beam is coming like this, and this is your diffracted beams, and this is the angle of your diffraction. Okay, so that's why the concept how you will get your diffraction patterns. So here comes your Bragg's law. Bragg's law is what? It is n lambda 2d sine theta. It will give you, it is mainly about your diffraction pattern. This is your interplanar. This is one plane, this is another, and this is your interplanar distance is your d. Lambda is the wavelength of your incident beam, and theta is your diffraction angle. So a quantitative expression for the relation between diffraction angle, wavelength, and interatomic distance by considering of an incoming wave at a set of equidistant lattice plane. Now, this diffraction is treated as a reflection of an electron wave at the lattice planes here. Now, when this equation that is valid not only for diffraction of electron, but for the X-rays and neutrons as well. So when you will study the XRD, there also your Bragg's law will apply. It is not just only for your diffraction of electrons, it is also for your X-rays. Then only you can get some crystal structure from your XRD also. The condition of constructive interference for two electron wave diffracted at two parallel lattice planes. The first one is what? The two incident electron waves are in phase with each other. After reflection at the lattice planes, the two waves have to be in phase again for constructive. So here, if it is in phase, then also after reflection, it should be in phase for the constructive interference. If it is destructive, then it won't be in the phase after what? After reflection. The distance that the wave with the longer path follows needs to be an integer multiple of the electron wavelength. So here this n is your integer. Okay, so this is mainly saying it should be integer multiple of your electron wave. So that's why n lambda equals to 2d sine theta. This is your incident angle, this is your reflection angle. This is your incident, this is your reflected electron wave, and lambda is the wavelength of your electron wave. So the thing is what here? Scattering angle of electron diffraction, scattering angle in compared to X-ray diffraction is what? Is smaller. Okay, here in XRD, in X-ray it is different. Okay, and in case of this it is different in electron scattering angle of electron. Now, did you guys join your live sessions also? Is it over or is it? The next question is, uh, I think people have actually not here, so I think I should take it in the next class. Maybe it would be better. So maybe I should stop this week lecture here only, and then we'll take our next. I have few more slides to cover this. Yeah, so that's all for today, guys. And we'll meet in the next class with few more questions we'll try to solve from this assignments. So yeah, I hope it is clear to you all. Let's meet in the next class. Goodbye and thanks.